Hi, this is Arun. In this video, we'll have a look at what is data structure and why it is always paired with algorithms. Okay, whenever they say these two together. Okay, but and also there is another myth. This is one of the complex thing which nobody can or which is very hard to understand, and it will trouble you. Yeah, this is a general myth students are having or people are spreading, but it is not like that. It is one of the easiest things which you can understand if you are able to look it in the right perspective. For example, it's like a math. Okay, if you understand the purpose of math and why you are solving that, it'll be easy. But without that, like some most of the cases, we do blindly. So in that case, it's tough. Let's start with what the fuck. I mean, what the fish is data structure. Okay, let's assume like you are moving from one place to another. Okay, you have different modes of transportation: train, bus, flights, all those things. Okay, so which one you will pick? If I ask you, so your first choice would be flight. Okay, given an option, then I'll say that if I don't have money, or you have to pay from your pocket, then you will think of the other things. So like that it goes on. So based on the constraint and your need, your ability or the choice of transport differs. Okay, the same thing let's apply to computer science. So ds and algo helps you to understand which one to pick it. There are hundreds of ways to do solve a problem. Okay, so which solution is the best and how I'll be able to find it out. So there are techniques for it. Okay, which is uh, generated over the period of time by a lot of people. Like we have our common knowledge passed from father to grandfather, all those things. It's the same way here we have it. Like so, data structure is nothing but helps you. It's a way which will help you to a data structure and algorithm. Understanding these things will help you to pick which one and why we need it. All those things. Okay, let's start with some analogy. Okay, as usual, we are good in that. Like we love hearing that. So data structure is nothing but your capacity and efficient decides your capacity and efficient usage. Let's take the same analogy like a train or a bus. Let's assume train is the efficient one which we have seen in the figure. Like we have packed almost everyone in the train. The entire city is or the town is put up in the small train. Okay, uh, is it right to use it in all the places since because it is efficient in packing all the stuff? No. If you are going for a city drive in the local thing, it's always good to go for a smaller size, mid size car if you are able to afford it. Okay, and algorithm is the engine of the car or the train or whatever it is. So it determines the speed or the efficiency of the stuff. Okay, no matter even if you have a smaller design or a smaller thing, if there is the engine is not proper, it's just a box with the wheels, that's it. Okay, so these two guys go in hand, like size as well as the efficiency. Both are combinations. Like if the size goes bigger, the efficiency goes smaller. So you should decide when which one to use when. Okay, the same exact logic applies to computer science as well. Like you have different data structures which can hold data, like stack, queue, arrays, or link, heap, binary trees, binary search trees, all the stuff like hash tables. Lot of things are there. Those are called data structures. But when to use the data structure is determined by the application or the algorithm. Okay, so then comes the algorithmic analysis. In the algorithmic analysis, we first look upon two things. One is the mileage, another one is the efficiency. So here it is size and the time. For example, let's assume I write a program which consumes 1 GB of memory, okay, for printing my name. It prints the name, it does it, but it is not size efficient. Okay, so the same way if I want to travel from one place to another place, so if I pick the smallest car, if I go to the T Nagar, you are locked. Okay, so if in the best case if I drive the same car in ECR, it will be different. If I go and sit inside the city other than T Nagar, it will be at least I'll get average mileage. So these are the terminologies which we have it. The size is called space complexity. The time is called time complexity, and every space and time complexity has a best, worst, and average case. Typically people go for the worst case. So if you are prepared for the worst case, you will be able to face any other case. So that's the general idea. Okay. So what we have seen is, like, first we start with the DS, second we start with the algo. So how these two are paired up, and what is algorithmic analysis. Okay, the algorithmic analysis consists of two parts: mileage as well as size as well as time. Okay, so let's dive little deep into it. So how to perform or why to do analysis. So these are some of the things which will help us while doing the analysis. Like, for example, how the algorithm performs. Okay, on an average case, let's assume I put up more data into it, how it scales up, whether it crashes or not. So, and I can compare the same solution with the different algorithms, which algorithm works better, or which is giving me the optimal solution. It's not always to be the best solution, which is optimal for my need is the key challenge. Okay, these are some of the results you will get out of a algorithmic analysis. The second set is the data structures. So I have picked an algorithm. So if I pick the right data structure, my algorithm's performance would be much better or enhanced. Okay, because these two are the paired thing. Like, so if I store it in an array, how fast it would be. If I store it in a tree, how fast it would be. So shall I pick this or that? So all those things are paired together. Okay, that's why from the first I was insisting these two to be in conjunction with each other. Okay, there is a famous quote which is like what is an algorithm, or any program which you write is an algorithm, and it has a data structure. If you have a variable, that's a simple data structure which you have it. Okay, algorithm is nothing but a few lines of code which you have written to solve a problem. Okay, so the bottom line is, like, if you have programmed already, at least written one program, then you are a algorithm developer. Probably your algorithm is you have solved your own problem. So next you try to solve someone else's problem. There we'll find the efficiency. Thank you, friends. Bye bye.